Okay, so the plan for today is to go over an old exam. By old, I mean last winter, so it's only a year old. I believe it's the most recent one you can find on Exambank. Okay, so let's take a look. So it's got 5 questions on it. First question is just very, very short answer type questions. And then the rest are a mix of programming / short answer questions. So let's just quickly go through this. So the short answer questions, they're the same as on any test. They're set up to basically, if you've been paying any sort of attention in the course, they should be more or less automatic for most of them. State 1 of the 2 standard forms of main. So that should be straightforward. Sorry, wrong program. Okay, one of the 2 standard forms of main. So there are 2. The test does not. Sorry. That's number 1. The test is if you look inside the test, you won't actually find the answers. So you would have to remember stuff like this, for example. So those are the 2 standard forms of main. Either one's fine. Got too many windows open, sorry. Where did it go? Here. Okay. Okay, so what is meant by the term pointer dereference? So if you dereference a pointer, you get the object that's being pointed at. Yes. Right, and so when you fill in your answers, don't answer them by saying the term pointer dereference means blah 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 blah. You don't have to write incomplete sentences. Point form's fine, right? STRT, okay. So so in previous years we would do input output a little bit earlier in the course. So we'd talk about STRT, okay, earlier in the course. This year I didn't talk about it until the last lecture, so that's probably not going to show up on the exam. So STRTOK remembers where it stopped processing a string the last time you called it. How do you do it? Or how does it remember? Well, it's got a static variable inside of the function, right? So remember a static variable, right? So a static variable lives for the lifetime of the program, even if it's defined inside of a function. And so that's how STRTOK remembers what happened the last time it was called. D. What, if anything, is wrong with the following function declaration? So this function says it returns the maximum value of that array. Right. It looks like that array was passed in by pointer, so it's passed in by pointer to int. Right. Returns the maximum value, and it says that that array can hold any int values. Right. So that comment is important. Right. The fact that it can hold any int values is significant. It's trying to say there's no special value inside of this array to indicate the end of the array, right? Once you realize that, you'll realize the caller doesn't specify how long the array is. So there's no way for the function to determine how long is the array. So the function cannot determine the length of the array. E. C. Oh, this was a repeat of one of the questions on your previous test. So any numeric value can be treated as a Boolean in C. What values are equivalent to true? And be as complete as possible in your answer. The answer is any non-zero value. Oh, any non-zero value, right? Is considered to be true in C. Right. That includes like floating point values, which is strange, but that's the way it works. F. Void has at least 3 uses. State 2 different uses of void. Okay, so void can be used as so function returns no value. Function has no parameters. Pointer. And if, it would be nice if you remembered that a void pointer can point at any object in the in C. G, the name of an array is synonymous with a pointer. What does it point at? It points at the first element of the array. I never told you this, but you can also, if you have a pointer to a struct, then the pointer actually points at the first member of the struct. Although you don't need to know that for the exam. Okay, so you can imagine you can actually look at the individual bits in a binary integer number by examining exactly one bit. How can you tell if it's negative? And a variation of this question would be, here's a binary number. Extract, tell me if it's positive or negative by only looking at the bits. How would you do it? Right. So in other words, what code would you actually use? Right. And so this one is just asking you, do you know what a 2's complement binary number is? Right. So it's negative if the most significant bit is 1. Right. Or the leftmost bit would be fine for the purposes of this course. Right. I. An int variable stores an integer value. What value does a pointer to int variable store? Pointers always store memory addresses of objects. Right, so in this case, it would store the address of the int being pointed at. J, 2 pointers P and Q. There are 3 general cases where P equals Q is true. State any of the 2. Okay, so P and Q are equal and they're pointers. So in 1, they point at the same object. Right. Now remember the 2 pointers being equal tells you nothing about the value being pointed at, right? So you don't know that the values of the objects are equal, but you know that they are pointing at the same object. The more obscure one is that you have 2 pointers and they are both the too far pointer. Right, so remember the too far pointer is the pointer into an array that is 1 past the last element of the array. Right, and so remember C guarantees that that pointer exists. One more? Anybody remember? Never mind, they are both null. Right. So those are the 3 cases where 2 pointers can be equal. Right, again, it tells you nothing about the fact that the 2 pointers are equal tells you nothing about the actual value of the object. Hey, what is the too far pointer? Okay, so that's easy. We just answered that. The pointer to the element 1 past the end of an array. Right. So if your array has length 5, then you can point at, you are allowed to point at the element at index 5. It doesn't exist, but the pointer is allowed to exist. Main difference between malloc and calloc. This one you can answer by looking at the reference page. So I give you a reference page at the very end. And so here, there's malloc and there's calloc, right? So you can tell that the difference between them, so the difference between them, there's a few ways you can answer this, right? Calloc takes in 2 parameters, malloc takes in 1, right? Or probably the answer that I was actually looking for, calloc zeroes out the block of memory, malloc does not. So you do get a reference page. I will post the reference page, the actual reference page for this exam later this week. Calloc zeros. Right. So calloc zeroes out the memory, malloc does not. In a generic stack, so remember a generic stack, we implemented the stack where the elements are, we don't actually store the elements in the stack, you store pointers to elements in the stack. What data type is used to store the elements in the stack? So we use a pointer to void, right? Because we don't know what the user is going to want to put on the stack. Okay, car occupies 1 byte of memory. How much memory is required by a variable that stores an empty string? So remember in C, all strings are null terminated. Oh, well, all correct strings are null terminated, right? So that means they must have the character \0 or the numeric value 0 in them. And that means there has to be at least one character, even in the empty string in C. So 1 byte or the null terminator, right? The null terminator is a car, right? So single quotes \0, right? Not double quotes /0, not double quotes \0, not double quotes 0, right? There's all sorts of funny answers on the test. Single quotes \0. Last question. After finishing reading or writing to a file, what should the programmer always do with the file? Very briefly explain why. Should always close the file. To release any resources back to the operating system, right? And that would be sufficient there, right? Again, notice the answers are very short, right? I don't want to read a long answer. You don't have to like write an essay for all of these answers, right? It takes too much time on the test. You should be able to answer question 1 in 5 or 10 minutes. That's the hope anyway. Okay, 2. All right, so an assessment item for a course is an item that receives a grade, right? So every assignment or test or whatever has a grade. For this particular question, every item has a name, test 1, a maximum grade out of 30, right? And a weight, so I guess 15 or 20%, I don't remember what it is. This one asks you to find a C struct that can store the information for an item. It tells you that the name is less than 128 characters in length. The maximum grade is an integer. Weight is a floating point value. Find structure. This is pretty straightforward, right? So struct, give it whatever name you want. I'm going to call it item. You need a name, right? It has to be, it says use a string of less than, whose length is less than 128. So I can just make an array of length 128, and that's fine. It has a maximum grade that's an int. So I need a max. And I have a weight that is a double or floating point. So I'm going to have a weight. That's it. Next question is provide a type def for your structure. So remember, type def always begins with the word type def, right? Second part of the type def is the name of the actual type, right? So the name of the actual type is struct item, right? Remember, in a struct is part of the type. Right, and then the third part is your alias or whatever you want to call item. So you can call it whatever you want. It doesn't matter what the answer is here. I'm just going to call it item. And that would be sufficient, right? Could be item, could be IT, whatever you want. IM, I guess, something like that. So that's A, there's B. C, write a function fill item that has the following parameters. So fill item wants to make a new item and basically return the item back to the caller. And it wants you to return a pointer to a newly created assessment item. It should have the name that was given by the caller. It should have the maximum grade that was given by the caller, and it should have the weight that's given by the caller. Right, there's even a little example here of calling the function right there. Right. Now it does go on to say some more. Here we go. So the newly created item should be independent from its input arguments. So for example, if you change or if the caller changes this, then the assessment item, its name does not change. Right. So in other words, the assessment item's string needs to be an independent string from the string that was passed in by the caller. That means you have to use string copy or something to copy the string into the assessment item. Right. It wants you to return a pointer, so we have to dynamically allocate an object. Right. So it wants a, so we have a type def, so I'm just going to use the type def here. Item star, fill item. It has a name, so star name. It has a max, so int max, and it has a weight. Okay, it wants you to return a pointer to a struct. So you can't make a local struct object here, because if you make a local one, it's going to disappear after the function returns. We must dynamically allocate a struct. Right. So item star I alloc item size of item. For the purposes of the test, I don't care if you test whether or not I is null. Right? If you want to be paranoid about it, test if I is null, and if it is, return null or something like that. Right? I'm not going to bother. I'm just going to fill in the fields of item now, of I. Right? So the max and weight are easy. Right? Now remember, it's a pointer to a struct, so you should use the arrow here. Right? So I max is equal to max. I weight is equal to weight. Okay, now what about the name? So the name, the question says the struct's name has to be independent from the name that was passed in. Right, so you have to do an actual copy here. The easiest way to do the copy is with string copy. So str copy into I name, name. And that's it. You're done. Right, return I. Like that. Okay. So that's all you had to write for that function. Yes. I guess there should be. So let me see. What does the actual question say? No, it doesn't look like there's any error checking required here. Okay, so that's fine. Normally, I'm not going to ask you for error checking. So if I'm going to ask you for error checking, I'm going to be explicit about it. To do the error checking, I mean, it takes time on a test, right? So normally I don't ask you to do it. If I do, it'll be explicit in the question, right? So here it would say something like, if allocating the object fails, return null or something. Okay, this is the one of the data structure questions. It asks you to consider the generic stack data structure. Could be any generic data structure though, right? I could ask you about a list or a queue or whatever. They're all the same thing at the end of the day. Now remember our stack. Sorry, there's a typo here. There should be a stack star s. There we go. Okay. So stack push pushes an element onto the stack. Right. Remember that the elements in our generic stack, they're not actual elements themselves, but rather they are pointers to the elements. Right. The pointers are represented as void pointers. Okay, so here's a little function called push zero. It pushes a 0 onto that stack S. Right. And so what do? They make a double value 0 or Z. Right. That's a local variable. Right. Or a automatic. That's a variable with automatic storage allocation. It won't exist after this function returns. Right. That function there pushes the address of Z onto the stack. Right. This is bad. Right. So after calling the function, is the top element the stack a pointer to the value 0? Explain why or why not. The answer is no. There is no object being pointed at after the function returns. No, Z has automatic storage duration. So if you wrote something like that, that would be fine. You would get full marks. If you wanted to explain Z doesn't exist after the function returns, that's fine too. But I know what automatic storage duration means. If you use that term, I assume you know what it means too. So that would be fine. B is between. Okay, so we've got this function here called is between. It takes in a pointer to an element. Right. So this function returns true if the element that E points at is greater than some minimum value and less than some maximum value. Right. So apparently, I guess presumably the minimum and maximum value will be defined inside the function itself. Fine. Create a variable whose type is a pointer to a function. Initialize its value so it points at is between. Okay, so here you need to remember, how do I make a pointer to a function? Right. So all you do is you copy the function. Right. That's literally all you do. Paste it, or just copy it from the copy it down in the test page. Right. So there's your function. Now you replace the name of the function with the name of your pointer. Right. And you put it inside round brackets and you slap a star in front. So star to indicate that it's a pointer. Give it a name. P. Right. There's your pointer. Right. And it says, make it point at the function is between. Okay, so that's equal is between. That's it. Right. You can write address is between if you like. You don't have to. Okay. So remember, if you have a function, then a pointer to the function is obtained by replacing the function name with a pair of round brackets and then star followed by your pointer name. And away you go. Okay, next question is implement is between where the minimum value is 0, maximum value is 11, and e points at an int. Right? Now the trick here is that you have to remember that the function is defined such that its type is pointer to void. So I need to make this a pointer to int. Right? It's actually defined as const pointer to void. So I guess I really should make this const pointer to int. Right? And I can just write that. Right? You can write the cast in front of the e if you want to. You don't have to. Right? And C, you can convert a pointer to void. You can convert a pointer to void to any pointer type without the cast. Right? But you need to cast it to int, or you need to store it in an int variable so that you can dereference it. Right? You can't dereference e directly because that will cause because you can't dereference a void pointer. Right? The reason you can't dereference a void pointer is because void can point at anything. The compiler doesn't know what is it pointing at. Right? When you store e in a pointer to int, right now if I dereference p, the compiler can assume that p is actually pointing at an int. Right? And so this says return true if p is between 0 and 11. Right? Or what is it? What does it exactly say? Greater than some minimum value, less than some maximum value. Okay, greater than 0, less than 11. Fine. So return star p greater than 0 and star p less than 11. And that's it. You have to dereference p because you've got a pointer and you need the value being pointed at. Okay. This should not surprise you. The next question asks you to use your pointer to a function inside of a new function. So COUNTIF is supposed to count the number of elements in S that are between 0 and 11. Right? And so if you look at the question, it tells you how is our structure implemented? Well, it's just a sequence of nodes. Right? Our stack has a pointer to the top node, right? It wants you to write this function here. Notice it leaves out this part here, right? Because that part there is the answer to part B, right? You need a pointer to a function that can count, that can determine if a value is between two values, right? And so that's left out. You have to figure out, oh, I actually need this parameter here, right? Why do you need this parameter? Because inside the stack class, right? The only thing, oh, sorry, not the class, sorry. Inside the stack implementation, the only thing you know about the elements is that they're pointers to void, right? If you want to do something with the elements, you need a function that can do something with the elements. So you got to fill in that missing function. Okay, so what is the thing that you fill it in with? Well, you fill it in with something that looks like this. Right, there's my pointer p to a function that returns true, given some constant, given a pointer to some element e. Right. Inside the function, you're going to use p to call the function. Okay, count the number of elements in the stack that are between those two values. So this means you have to iterate over the elements in the stack. Oh, wait. Right. Okay, so all you have to do now is remember, well, how do I iterate over a sequence of elements, right? Don't forget the special case where the stack is empty, right? Because if the stack's empty, you want to return 0. And you don't have to do the iteration, right? So I guess we'll deal with the special case first. So S, go back and look at your question. We know the size of the stack. So the size is 0. Whoa. Or 0. Right, there are no elements between 0 and 11. Right, otherwise you just walk over the sequence of nodes. So it's always the same. It's always the same loop, right? Make a pointer to a node, set it equal to the top node. Right, if you're a list, set it equal to the front node of the list. If you're a queue, set it equal to the front element of the queue. It's all the same stuff. While n is while n is not null, or just while n. Whoop, what happened? Okay, so while n actually points at something, I guess we want to get the element that n points at. So that, right? Don't try to dereference n elem. That's not going to work, right? I now want to know, is the value of e, or the value being pointed at by e, is it between 0 and 11? So p is the thing that can tell me that. So if p, e, right? P is the pointer to my function, e is the element, that thing returns true if the element is between 0 and 11. So it looks like I have to increment the count here. And it also looks like I need a count somewhere. So up here, int count equals 0. The question says use int. You could use on some sort of unsigned type here instead. Right? Add 1 to the count. Don't forget, right? What's the last thing you do in these types of loops? Well, you always advance n to the next node. That, right? Yes. What is, sorry?
You start the line 8.
Oh, hey, sorry. It's because I teach Java. STOP, sorry. It's because I always get confused between 124 and this course, right? Thank you. Right, return the count. And if you look at that code for a second, you realize that the special case actually isn't needed, right? Because the loop won't run, because stop will be null for the empty stack, right? And you return a count to 0. So that's technically not needed. Any questions about that particular question? All right. Almost done, and we've only been here 27 minutes. String comp. So string comp, this question asks you to implement the C, a function that duplicates the functionality of string compare. Right, so remember string compare returns -1, 0, or 1. If the left-hand side is less than the right-hand side, if the left-hand side is equal to the right-hand side, or if the left-hand side is greater than the right-hand side, or left-hand side and right-hand side are two strings, right? So to answer this question, you have to basically figure out, how do I compare two strings, right? The answer is that you compare them character by character, right? If they're equal, then that's fine. You have to compare the next characters, right? As soon as you find a character in the left-hand side, so when you compare the two characters, you're just going to compare them as two numbers, right? That's what the hint at the bottom is telling you, right? So values of type char are just integers. So if I want to know, is the letter A less than the letter Z, I can just write character A less than character Z, and away you go, right? Some of the tricky things you have to deal with here are the lengths of the two. What happens if the two strings have different lengths, right? You have to make sure that you write your loop so that it doesn't fall off the end of one of the two strings. And how do you return the value after you finish looking at all of the elements in the shortest string, and your two strings are still, you still haven't figured out what the answer is yet, right? So if you have ABC compared to ABCDE, right, you'll fall off the end of the first string. The first string is less than the second string, so you have to figure out how to deal with that case as well. However, it's not hard. Okay. So what do you need to do? So our loop is going to look like this. Okay. So that's going to be my return value, right? So comp is my return value. I'm going to assume it's 0. You know that arrays in C are never empty, so you're always allowed to look at the first element in both arrays. Right, so I'm just going to look at the first element in both arrays. I'm going to call them left and right. Right, so left is the character on the left, is the first character of the string on the left. Right is the first character on the string on the right. Right, now I just loop. Right, when you loop, you have to make sure that you don't go past the null terminator in either string. Right. I guess I can start at 1 because no, I'll start at 0. Okay, so for I equals 0, right? The loop should run as long as my left character is not the null terminator and the right character is not the null terminator, right? Okay. So I've got left and right. I want to compare left and right, right? and I want to store, and I want to return, remember, negative, positive, or 0, right? Negative if left-hand side is less than the right-hand side, positive if the if left-hand side is greater than the right-hand side, and 0 if they're the same, right? So all I'm going to do in this particular case is subtract the left-hand side, right-hand side. Right? So if the two characters are, sorry, not left-hand side, right-hand side, left and right. Right? If the two characters are the same, then the difference is 0. Right? If the character in left is greater than the character in right, then the answer is positive. If the character in left is smaller than the character in right, then the answer is negative. Right? The loop only has to continue as long as comp is not, as long as comp is 0. Right? As soon as comp is not 0, you're done. Right? So if comp is not 0, you've got an answer. Right? So I can just return comp. Right? I've looked at two characters and I've looked at two corresponding characters in both strings, and they are different. So I know that for sure one string is less than or greater than the other string. Okay, if you get to the end of the loop, then that means you've either looked at all of the characters in the strings. Sorry, you've looked at all the characters in at least one string, and you haven't found a difference between the two strings yet. Right. Okay, so alternatively, you've looked at all of the characters of both strings, and they're the same. Right. So comp is still 0. So if the left-hand side, so now you just determine which string did you actually run out of characters in. Right. So if sorry. So if they're both the same, well, sorry. Right. So I'm not going to try to be clever here. I'm just going to brute force the answer. So if they're both the null terminator, then the strings are equal. Right. Okay, so if left is equal to the right-hand side, sorry, if left is equal to the null terminator, right? Then you know that there's still some characters left in right. Right? There's still some more characters in right. And that means left is less than right. So I can return -1. Otherwise, I must be in the case where left is not the null terminator and right is the null terminator. Right? That means there's still characters left in left, which means left must be greater than right. So I can return 1 in this case. Right. If you wanted to actually behave like string comp, you would return minus right here and you would return left here, but it doesn't matter. Right, for this question. Okay. Last question, which we should finish. Okay, so your last question will not be this involved this year because we didn't really talk about reading from a file very much. You still have to read from a file. The file that you have to read from will not be, the reading problem is not as complicated as this one. And even this problem is not super complicated. So the question is asking you to write a program that can read a file that looks like this. Right? So the file, each line consists of an integer followed by a comma, followed by a string that is of length equal to the integer. Right, so that integer just tells you how long is the string on the rest of the line. Right, so the first line contains a string of 5 characters, the second line contains a string of 4 characters, and so on and so on and so on. Eventually, you get to a 0, right, which indicates that this is the end of the file. The question says you don't know how many lines are in the file. It also says you don't know how long the strings are. Right, the strings can have any arbitrary length. So this number here could be like 1 billion. Right, and you're going to have to figure out how to deal with this. Right. So that's your file. You need to read in the file, and you need to concatenate all of these strings together to produce one final string. Right. So if you run a program, your program on that file, you should end up with this output. right? It gives you the fully concatenated string and the length of that string, right? It's 34 characters long. There are some requirements, right? So your program has to perform the necessary string concatenations, right? So in other words, you can't just read in the file and output the strings to the screen, right? You actually have to compute the concatenated string, right? When you're reading the file, you don't have to do any error checking, right? So you don't care if you run into a line that is misformatted or something like that, right? You don't have to worry about that sort of thing. You should not assume anything about the length of the file, and you should not assume anything about the length of a particular string, right? So you can't just make an array of length 1000 and hope that that's going to fit the concatenated string. And finally, if you are allocating any resources during the lifetime of your program, you have to deallocate all of those resources, right? Even if your function only consists of a main function. All right, everybody got that? Any questions so far? There's one more other thing up here. You have to test the number of command line arguments. And so you call the function, the program by passing in one argument. So your program has to test, is the number of arguments correct? Okay, so the funny thing about testing if the number, so the other thing you have to remember is you need to remember what is the format of this main function, right? The funny thing about argc in this in C, it's equal to the number of command line arguments plus 1, right? The first command line argument, the first argument to the program is always the name of the program, right? So here I want to make sure that argc is equal to 2, right? So 1 for the name of the program and 1 for the name of the file. So if it's not equal to 2, this is the error condition. It says the program should exit with an exit status of 1. So you can just return 1. You can also exit round bracket 1, which would be fine, right? Both do the exact same thing in this case. 90% of the class gets that wrong, right? 90% of the class tests if argc is equal to 1, right? You have to test if it's equal to 2. Okay, open the file. So file star f equals f open. Okay, name of the file to open. So the name of the file is passed in as a command line argument. Right, so it's one of the things in argv. Right. Which thing is it? The thing at index 0 is the name of the program. So that's not the name. It's not argv 0. It's the thing in argv 1. Right. So that's your first command line parameter. Right. How do I want to open the file? I'd like to open it for reading. So R. The question is a bit unclear here on whether or not you have to test if f is null. Right. It says here when reading the file, no error checking is required. Right. So am I reading the file at this point? Debatable. Right. I guess you really should test if f is null. Right. If it is, I'm just going to return 1. Right. You really should test whether or not the pointer is null, is not null, right? Sorry, yeah, if not f, right? So if it's null, that means it didn't open up the file correctly. You shouldn't try to read it. Okay, so I've got the file open now, and now I need to read in the strings in the file, and I need to concatenate them into one big string, right? So I can't make a giant array here, or I can't correctly make a giant array here. Okay. So the problem here is that when you're concatenating the string, you may have to expand the size of the string. The only way to expand the size of the string is to dynamically allocate an array here, right? So I'm going to dynamically allocate. I'm just going to call it S. Right? It doesn't matter what you put in here. It has to be bigger than 0. You can make it however long you want. Right. So I'm going to make it 1. Sorry, let me do it this way. So I'm going to make a variable called capacity, which is the capacity of my string. Right. You can choose whatever you want here. Doesn't matter. I'm going to make 100. Right. Allocate the string. So this is, remember, this is going to hold my concatenated string. All right, so now I need to figure out, okay, so what is the length of the first string? Right. You could try to do this. You could jump right into the loop. It's a little bit trickier if you jump right into the loop. The pattern that I'm going to use here is the following. So the tempting thing to do in this question is to write a loop where inside the loop you read an int, then you read the comma, and then you read the string. Right? You can write it that way, but it's a little bit easier if you read in the number first, and then inside the loop, repeatedly look for the comma and the string, right? And then read in the number again at the end. So I'm going to read in the number first. That tells me how long my starting string has to be, right? So how do I read in the length of the first string? So size t. Length equals. So how do you read in an int from a file? If you remember, you can use fscanf. That is the easiest way to do this one. Fscanf. So I'm going to scan the file f. I called it f, right? Yes. I'm going to scan the file f. What am I going to scan it for? Well, I'm going to look for an unsigned integer number. So that's %u. Where am I going to store the value? I'm going to store the value. Sorry. That's dumb. I'm going to store the value in length. Right now, remember, for the function to store a value in length, you need to pass it the address of length, right? It needs a pointer to the object. Okay, so let's do that. And now if you look at this for a second, you say, hey, that's a little weird. Why did I allocate the string first before figuring out how long it is? So now you pull out your eraser, you grab this, you move it down here. Right. Okay, so now I can make my concatenated string. I know that has to be at least length plus 1. Right. Malloc the string. Right. Why plus 1? Because I need to store the null terminator. Okay. Allocate the string, and now copy the string into my copy, or I'm going to inside the loop. I'm going to read in the string, copy the string into the into my array. Right. Okay, so create the string to read. Sure, let's do that. Oh, that's what I just. That's what I'm just doing here. So that's all done in one step, like there. Should I do this? Maybe we should do it this way. Yeah, let's do it this way. Star, next. I guess we should do it this way too. Okay, now I'm going to read in the file. Okay, so I've already read in the int, so now I want to read in the comma and the rest of this string. I want to use fscanf to do that as well. F, so I want to read in the comma, followed by a string. Right. I would like to read the string into next. And I know that next is big enough because we just allocated it here, right? And we allocated it correctly because we read in the number first and added 1 to the length. Right. What does it? You have to remember what fscanf returns. I'm pretty sure that on the page, on the reference page, you're told what it returns. It returns the number of successful conversions, right? You don't actually have to test if it's equal to 1. I'm just going to test if it's greater than 0. Right. So if it's greater than 0, I know it read in the comma and the space, the string correctly. Right. So that means I've got my string sitting in next. So I can now copy next into what? Into S. Right. So string copy next into S. Right. Now read in the next int. By doing that. Right. Okay. So now that I'm gonna read in that, I now want to okay, so after copying S into next into S, I now want to concatenate S onto S is create concat. Sorry, next. Sorry. I read it into next. Right, here we go. I don't want to string copy that. I want to concatenate that. All right. Concatenate next on to S. So that's string cat. Okay, read in the next. Read in length of next string. Repeat the process all over again. So next has sufficient room to hold a string of capacity, right? So I need to test whether or not length is greater than or greater than capacity. Right? If length is greater than capacity, then I have to reallocate my string, right? So if it's greater than capacity, I need to realloc S. So S equals realloc. How long does it need to be? It needs to be length plus 1. Or alternatively, redefine capacity. Right? And then reallocate a string of that capacity. Okay, don't forget, you also need to allocate enough space in the, sorry, that's S. I also need to do the same thing for next. Sorry, this is actually incorrect. Something's missing here. Next equals realloc. That. Right. So how much space do I need in S? I need the length of S plus the additional capacity, right? Because remember, S is the concatenated string. Question? If the length is greater than. Thank you. So length plus yes. Very good. Yep. I probably wouldn't catch that on the test, to be honest. Anyway, so it's greater than capacity, reallocate both strings, right? And away you go. Right. Now, reallocating the strings here is the way you want to go. What you don't want to do is you don't want to call malloc here, right? Or calloc. If you call malloc or calloc here, you're going to leak the old strings, right? And so in other words, there's no way for you to release the memory that you allocated previously, right? So you have to remember to use realloc here, because at the end of all this, I can just release S and next, and everything will be fine. Okay, that's good. So and now we repeatedly concatenate onto the end of the string. Okay, so how do we know we can stop? We can stop if the length is 0. Like that. All right, let's make sure we got everything right here. So read in the number, read in the string, concatenate the string onto S, right? Read in the next number, reallocate S and next if we have to, and then repeat the process. Okay, when you get down to here, you're basically done. You have your string S, you can get its length just by calling string length, right? And so the question wants you to print the string length, percent U. Percent D works here too. So print the length of the string. Next line, sorry, it wants you to print that on one line. So I need the new line character here. Right. And then finally print the string itself. So fprintf, S, percent S, or just use fputs. Both work fine here. Right. And then S. Finally, don't forget to close the file and free the strings. So which strings did we allocate during the lifetime of this process? There was S and there was next, right? And then close the file. Right, I suppose if you want to return 0 here. And there is the last question. That's one solution for the last question. There are other ways to do this question. Instead of reading in strings and constantly reallocating stuff as you go, you can read the file once, right? So just scan the file, count the number of lines in the file, right? You can just use fgetc and count the number of new line characters that you read, right? So while fgetc is not equal to EOF, right? If the character that you read is the new line, add 1 to the counter, right? That tells you how many lines are in the file. So that solves the number of lines in the file problem, right? Alternatively, you can count the number of lines in the file and figure out how long the total string is, right? So in other words, just read in the int each time, discard the rest, don't worry about the string. And that gives you the total length of the string. You could also do it that way, right? Or combine the two together and do it that way. So when you read in the file once, you rewind it and then read in the file the second time, this time reading in the strings and joining them onto the final concatenated string. Right, so there are many ways to solve this problem. Again, your problem this year is not this involved. It's quite a bit simpler than this particular version. But if you can do this, you can easily do this year's test. No problem. Okay, any questions about yes? No bash, it's all C. Yeah. I'll post an announcement about that too. But it's just C in this for the exam. Any other questions? All right. We're all question.
You're only adding as the length of the term.
Oh yes, thank you. That's no, that's not true. We string cat up here. We only realloc if the next string if we have to. Oh, sorry, you always have to realloc S, don't you? Thank you. You always have to realloc S. See, I probably wouldn't have caught that either on the test. So realloc capacity, I guess I should do, I guess now that you've mentioned it, we should cut that out from here and put that up here. That's better. Yeah, that's correct. Oops. Good. Any other questions? Okay. I guess that's it for the course. The TAs will be marking the 5th assignment this week. Probably, I don't know who's going to mark your 6th assignment. It might end up being me because most of your TAs are actually undergrads and they're going to be doing their exams. So assignment, you should get your assignments back though before the exam. And all of the assignment solutions will go up sometime this week on OnCue. All right, if there are no other questions, I will see you at the exam or during office hours. I have extended office hours starting on Wednesday, so I'll post an announcement about that on OnCue as well. Yeah. Yeah.
Or you just making it to prepare us for the exam.
Yes, for sure. Yeah. 4 would be good too. So 4 is for the basic stuff. Yeah. But yeah, 5 and 6 would definitely be worth looking at. Oh, and there are also many old exams on OnCue. So going back several years. A lot of the older exams aren't really relevant to this version of the course. Well, the whole exam is not relevant because people would used to test you on bash as well. And so I think I've marked the quote unquote relevant questions on the exams and you have solutions for those as well. It's all in OnCue under the past exams section.